Okay, everyone, welcome to the next presentation of this session. We will talk about API design and why you should think before you do. So when you are designing an API, you have a goal in mind that the API must fulfill. It can be that your API must be innovative. It can provide connectivity to other parties. It can be to have a flexible microservice landscape, to integrate with third parties. Well, there are a lot of goals to that an API can fulfill. So to get those goals, to fulfill those goals, you will have to need you need a good API design. And a good API design, of course, that starts with good API design guidelines. That's also what we will talk about in this presentation. We will look into API design, the goals and some tips, and later on we will look into the API design guidelines. So what is an API? Well, an API is actually the blueprint of an API. It describes the resources and the actions that you can do on those resources. It also gives an overview of all the endpoints, and it provides documentation for your own developers and as well for the consumers. So a good API design is actually an enabler. It enables you for development speed. When an API design is very clear, the task for the developer is as well very clear. He or she immediately knows what he can do and how to do it. Also, an API design is also an enabler for user growth. How is this an enabler? Well, a good API design designs effective APIs, and effective APIs, those are APIs that don't give too much information, but also don't give too little information, because too much information will take a lot of bandwidth, and too little information, that will create a chatty API. And a chatty API, well, that gives more requests to the server, that will also impact the scalability and the durability. So when you have a good API, or an effective API, you have a scalable API that's durable and reliable, so you can easily grow your user base. API design can also impact the developer usability. I mean, for the developer usability, the consumer usability. When an API, as I said, that describes the blueprint, that's actually the blueprint of the API, and so it will help the consumer understand the API, use it, and integrate with it. And the fourth enabler is the profit gains. So when the development speed is higher, your development cost will be lower. When the API is effective, you need less resources, so you have less runtime costs. And also for the developer usability, when an API developer, a consumer, uses your API and he thinks that's very bad, he will quickly drop the API and will not use it anymore. But when when you have updated your API, then you will have to make a lot of advertisements to get your developer again to use your API. So now we looked at why API design matters. Now we will look at API design guidelines. What's the difference between API design and API design guidelines? Well, API design, that dictates how the API will look like and how you can use it. API design guidelines, they create standards for designing an API. And standards, well, they are very important because ideally all APIs will look like the same author created them. To give you a quote about why standards matter, I have searched for a quote for api.org, and I will give you some time to read it. So you may have seen some weird parts in that quote. Well, that's because api.org, that's not of application, not the API we know, but it's for American Petroleum Institute, and it's a quote about standards in the oil and gas industry. And there are, well, actually some parts that are very the same, that matter the same in that industry as with APIs that we know. The first thing that's important is that standards help to assure quality. It also helps to speed the acceptance, because when the standards are known, you will have to the consumers don't have to learn as much to use that API. And the last one is it helps you avoid having to reinvent the wheel. Well, when you have designed an API, you know that there are a lot of discussions that you can partake in, like for example, the casing of query parameters. Do you use kebab case, snake case, camel case, whatever. So when you have a good standard, you know which casing you have to use in your query parameters. But API standards are not enough. You also have to promote them. You have to promote them in your whole team, in your whole company. This means to the designers, to the developers, and to the testers. Your guidelines will have no value if no one will read them or respect them, so everyone should know about them. This is actually a tip of Arnaud Loret. He has made a site that's called the API Style Book, and there he collects a lot of API design guidelines from very well-known parties like Microsoft, Zalando. So when you are researching your API design guidelines, you can take a look at the API Style Book. Next, what should the API guidelines cover? Well, the first decision you have to take is which architecture will you use? Will you use REST API, gRPC, GraphQL, or webhooks? That's a big decision that will impact your API a lot. REST APIs, that's a very well-known standard. The benefit of a REST API is that it's stateless, so you can scale it very easily. It also has hypermedia that allows you to loosely couple your client and your server. It also builds upon HTTP standards, so you can use HTTP methods or HTTP status codes. So there you can use already known standards. Well, when should you use it? Well, it's a good standard for most APIs. When you are doubting which architecture you should use, then you will probably do nothing wrong with using a REST API. gRPC, well, that's actually the modern implementation of an RPC framework, and RPC stands for Remote Procedure Calls. What it does is it allows you to execute a procedure on a remote server, RPC, Remote Procedure Call. It's a very lightweight framework, and it allows you to, when you are working with fixed data structures, or when you are executing procedures that you are executing a lot, then it has a big benefit over REST. When should you use it? Well, it's mostly used in microservices and in IoT because it's very power and resource friendly. GraphQL, the one on the left bottom, that's well an different way to get or retrieve information from the server. With REST, you have a defined response body. With GraphQL, the user defines what data that they want, how they want it, and in what format that they want it. GraphQL is actually the implementation of that ID from Facebook. OData is Microsoft's implementation of the same concept. When should you use it? Well, it's best when the client needs the data in a specific format so that he can choose how to get it themselves. And the last architecture design is or possibility is webhooks. And webhooks, well, that's a different way to retrieve information. You have with REST APIs or gRPC or even GraphQL, the consumer polls or asks the server for information. With webhooks, the server will provide information to the consumer when there's something happened at the server side. So the data, the updates, the events are automatically sent to the consumer instead that the consumer requests them. A good example to explain it is the example of Foursquare, where you can check in a bar that you are there. Well, the server of Foursquare will send a message to all the clients that are listening for that event, so they don't have to poll every 5 seconds to get that event. The front-end design decisions, well, they are more important for REST APIs. So that's there you have to decide how the API should look like, which URI will you use, how do you provide parameters to them, query parameters or path parameters, which headers will you use, which status codes are possible. The backend design decisions, well, they impact on how the API will integrate with your backend. It's how you will transform or aggregate your data. And as well, something very important there is the error handling. How will you cope with errors? And then you have the non-functional design decisions. And there you should think about security. How will you use basic auth, OAuth, OpenID Connect, or something else? You also have to think about performance. You have to think about availability of your API, and as well the evolvability. How will you cope with a new version or a new change in your API? Okay, so now we come to the starter API REST design guidelines. Well, they are based on a lot of experience that we have within AE. We work in different industries, the banking industries, utilities, and others, and there we found out that actually in all industries they all have almost the same questions and the same problems. So we gathered all that knowledge, and then we distilled the best practices to get the API REST design guidelines. I will quickly pick some tips for you to help you improve your API designs. The first one is keep it simple. Do not over-engineer your API. Keep the URL simple. Do not try to discover your own guidelines. Try to follow the industry guidelines. The next one is use nouns, not verbs. So when you want to get information of your API, use the HTTP GET method. Do not make an endpoint get all products. That's related to the next tip, and that's use the correct HTTP method. So you have a get to retrieve information, a post to create information at server side, a put to update your information at the server side, and a delete, to delete the object. There's also those methods also have their own properties. So a get method is safe. That means that it is read-only. The API or the request will have no impact, no side effects. The idempotent of an HTTP method is that you can repeat the same call to that same endpoint with that method multiple times, and the result will always be the same. And next, we have the cacheability of an HTTP method, and so a get on an API of an API endpoint will always will not change, so you can cache it. Next, we have the versioning of the API. Try to keep your changes backward compatible. When you are introducing breaking changes, that will so try to keep every change backward compatible. But if you have to do a breaking change, well, use versioning. And even if you don't think you will need a breaking change, well, just put a version in there to allow you to create a new version of your API when the API should change in the future. There are a lot of strategies like URI versioning, media type versioning, or even others like query parameter versioning or custom headers that you can use to indicate the versioning. My tip is to use only one strategy and stick with that. The next tip is to use HTTP status codes. Use the 200 range for successful operations, use the 400 range for client-side errors, and use the 500 range for server-side errors. An extra tip is when you have 400 errors, so you have client-side errors, give as much information as possible. This will help your consumer to get to know what went wrong and to change their request so they get a successful operation. But for server-side operations, there you should keep the information as limited as possible. This is to reduce the knowledge about your system, about your network components to the consumers. The next tip is that you should use OpenAPI Specification, OAS, also known in the previous version as Swagger. Well, the Swagger is, or the OpenAPI Specification, is a standard interface for describing your APIs, especially RESTful APIs. And then the next tip is work contract first. So what do we mean by that? Well, with contract first, you create your contract, you describe your API before you start the implementation. There's also the way to work code first, where you develop your API and then create the contract from that from the code. But we prefer the contract first method because it allows you to develop your side of the API together with the consumer. You can already give your API designs to your consumer, and then he can start with the development themselves. It will also give you clear communication with your consumers, so that's another benefit. And when you think about the API design first, you will follow the API guidelines more to the details, so you will get a better designed API. So now we looked at what the design guidelines must cover, which decisions you must think about. I also gave some examples of the most basic design guidelines, and you also know why API design is necessary. So now you can start with your design of the API and start building the best APIs possible. So that was my presentation. If you have any questions, you can ask them online, and Peter will help.
Yes, so the first question is basically about the usage of patch instead of put. I don't know what your opinion is on that.
Patch instead of put, well, there are some benefits about both. I can not give you a good reason why one of the two are better, but as I remember, the patch is easy. No, I will not go into that. Sorry.
Then the second question is what is related to API security. How would you protect an API against malicious bot attacks? It's a little bit off topic.
Yeah, it's. I think API security is a topic themselves. One tip I can give you is to have a load balancer or a good firewall in front of your API. So there you can already filter out a bit of the bot traffic.
And then I basically have a question related to API testing, and it's basically with which tools could you verify when an API is implemented correctly, so according to its specification?
According to its specification, well, I think there the testing approach is can help you with testing if your API is developed correctly. If you develop your API and your tester creates the test code, you can actually check if the API is developed correctly.
Yeah.